Chapter 1. You Are Here. The entire earth is but a point, and the place of our own habitation but a minute corner of it, said Marcus Aurelius, the Roman emperor, around 170. As the astronomers unanimously teach, the circuit of the whole earth, which to us seems endless, compared with the greatness of the universe, has the likeness of a mere tiny point, said Ammianus Marcellinus, the last major Roman historian. The spacecraft was a long way from home, beyond the orbit of the outermost planet and high above the ecliptic plane, which is an imaginary flat surface that we can think of as something like a racetrack in which the orbits of the planets are mainly confined. The ship was speeding away from the sun at 40,000 miles an hour, but in early February of 1990, it was overtaken by an urgent message from Earth. Obediently, it turned its cameras back toward the now distant planets, slewing its scan platform from one spot in the sky to another. It snapped 60 pictures and stored them in digital form on its tape recorder. Then, slowly, in March, April, and May, it radioed the data back to Earth. Each image was composed of 640,000 individual picture elements, or pixels, like the dots in a newspaper wire photo or a pointillist painting. The spacecraft was 3.7 billion miles away from Earth, so far away that it took each pixel 5.5 hours, traveling at the speed of light, to reach us. The pictures might have been returned earlier, but the big radio telescopes in California, Spain, and Australia that receive these whispers from the edge of the solar system had responsibilities to other ships that ply the sea of space, among them Magellan, bound for Venus, and Galileo on its tortuous passage to Jupiter. Voyager 1 was so high above the ecliptic plane because, in 1981, it had made a close pass by Titan, the giant moon of Saturn. Its sister ship, Voyager 2, was dispatched on a different trajectory, within the ecliptic plane, and so she was able to perform her celebrated explorations of Uranus and Neptune. The two Voyager robots have explored 4 planets and nearly 60 moons. They are triumphs of human engineering and one of the glories of the American space program. They will be in the history books when much else about our time is forgotten. The Voyagers were guaranteed to work only until the Saturn encounter. I thought it might be a good idea, just after Saturn, to have them take one last glance homeward. From Saturn, I knew, the Earth would appear too small for Voyager to make out any detail. Our planet would be just a point of light, a lonely pixel, hardly distinguishable from the many other points of light Voyager would see, nearby planets, far-off suns. But precisely because of the obscurity of our world thus revealed, such a picture might be worth having. Mariners had painstakingly mapped the coastlines of the continents. Geographers had translated these findings into charts and globes. Photographs of tiny patches of the Earth had been obtained first by balloons and aircraft, then by rockets in brief ballistic flight, and at last by orbiting spacecraft, giving a perspective like the one you achieve by positioning your eyeball about an inch above a large globe. While almost everyone is taught that the Earth is a sphere, with all of us somehow glued to it by gravity, the reality of our circumstance did not really begin to sink in until the famous frame-filling Apollo photograph of the whole Earth, the one taken by the Apollo 17 astronauts on the last journey of humans to the moon. It has become a kind of icon of our age. There's Antarctica at what Americans and Europeans so readily regard as the bottom, and then all of Africa stretching up above it. You can see Ethiopia, Tanzania, and Kenya, where the earliest humans lived. At top right are Saudi Arabia and what Europeans call the Near East. just barely peeking out at the top, is the Mediterranean Sea, around which so much of our global civilization emerged. You can make out the blue of the ocean, the yellow-red of the Sahara and the Arabian Desert, the brown-green of forest and grassland. And yet there is no sign of humans in this picture. Not our reworking of the Earth's surface, not our machines, not ourselves. We are too small, and our statecraft is too feeble to be seen by a spacecraft between the Earth and the Moon. From this vantage point, our obsession with nationalism is nowhere in evidence. The Apollo pictures of the whole Earth conveyed to multitudes something well known to astronomers. On the scale of worlds, to say nothing of stars or galaxies, humans are inconsequential, a thin film of life on an obscure and solitary lump of rock and metal. It seemed to me that another picture of the Earth, this one taken from 100,000 times farther away, might help in the continuing process of revealing to ourselves our true circumstance and condition. It had been well understood by the scientists and philosophers of classical antiquity that the Earth was a mere point in a vast, encompassing cosmos. But no one had ever seen it as such. Here was our first chance, and perhaps also our last, for decades to come. Many in NASA's Voyager project were supportive, but from the outer solar system the Earth lies very near the Sun, like a moth enthralled around a flame. Did we want to aim the camera so close to the Sun as to risk burning out the spacecraft's Vidicon system? Wouldn't it be better to delay until all the scientific images from Uranus and Neptune, if the spacecraft lasted that long, were taken? And so we waited. And a good thing, too. From 1981 at Saturn, to 1986 at Uranus, to 1989, when both spacecraft had passed the orbits of Neptune and Pluto. At last, the time came. But there were a few instrumental calibrations that needed to be done first, and we waited a little longer. Although the spacecraft were in the right spots, the instruments were still working beautifully, and there were no other pictures to take. A few project personnel opposed it. It wasn't science, they said. Then we discovered that the technicians who devise and transmit the radio commands to Voyager were, in a cash-strapped NASA, to be laid off immediately or transferred to other jobs. If the picture were to be taken, it had to be done right then, at the last minute, actually in the midst of the Voyager 2 encounter with Neptune. The then NASA administrator, Rear Admiral Richard Truly, stepped in and made sure that these images were obtained. The space scientists Candy Hansen of NASA's Jet Propulsion Laboratory, JPL, and Carolyn Porco of the University of Arizona designed the command sequence and calculated the camera exposure times. So here they are, a mosaic of squares laid down on top of the planets, and a background smattering of more distant stars. We were able to photograph not only the Earth, but also 5 other of the Sun's 9 known planets. Mercury, the innermost, was lost in the glare of the Sun, and Mars and Pluto were too small, too dimly lit, and/or too far away. Uranus and Neptune are so dim that to record their presence required long exposures, and accordingly their images were smeared because of spacecraft motion. This is how the planets would look to an alien spaceship approaching the solar system after a long interstellar voyage. From this distance, the planets seem only points of light, smeared or unsmeared, even through the high-resolution telescope aboard Voyager. They are like the planets seen with the naked eye from the surface of the Earth, luminous dots, brighter than most of the stars. Over a period of months, the Earth, like the other planets, would seem to move among the stars. You cannot tell merely by looking at one of these dots what it's like, what's on it, what its past has been, and whether, in this particular epoch, anyone lives there. Because of the reflection of sunlight off the spacecraft, the Earth seems to be sitting in a beam of light, as if there was some special significance to this small world. But it's just an accident of geometry and optics. The sun emits its radiation equitably in all directions. Had the picture been taken a little earlier or a little later, there would have been no sunbeam highlighting the Earth. And why that cerulean color? The blue comes partly from the sea, partly from the sky. While water in a glass is transparent, it absorbs slightly more red light than blue. If you have tens of meters of the stuff or more, the red light is absorbed out, and what gets reflected back to space is mainly blue. In the same way, a short line of sight through air seems perfectly transparent. Nevertheless, something Leonardo da Vinci excelled in portraying, the more distant the object, the bluer it seems. Why? Because the air scatters blue light around much better than it does red. So the bluish cast of this dot comes from its thick but transparent atmosphere and its deep oceans of liquid water. And the white? The Earth, on an average day, is about half covered with white water clouds. We can explain the wan blueness of this little world because we know it well. Whether an alien scientist newly arrived at the outskirts of our solar system could reliably deduce oceans and clouds in a thickish atmosphere is less certain. Neptune, for instance, is blue, but chiefly for different reasons. From this distant vantage point, of a fraction of a dot. Think of the endless cruelties visited